Number 4 says for x greater than or equal to 0, the horizontal line y equals 2 is an asymptote for the graph of the function f. Which of the following statements must be true? So if we look at A, f of 0 equals 2, that does not have to be true. F of 0 could be anything for all we know. And we know that y equals 2 is an asymptote, so my guess would be that we don't even have a y value of 2 in our graph. For part B, f of x cannot equal 2 for all x greater than or equal to 0. When I first read this, I thought that that one would be true, because if y equals 2 is a horizontal asymptote, then none of our y values could equal 2. But when I started thinking about it, there are graphs that look similar to this, where yes, this line y equals 2 is a horizontal asymptote of this graph, but only for this part. So really it's not even continuing on over here. It still counts as a horizontal asymptote because it is on this part of the graph, but it's not on this part of the graph. So these x values that are greater than 0 absolutely could have a y value of 2, like right here. This won't always be the case, but it could be true. So we wouldn't include B in our answer. Same thing for part C. It could be that the graph looks like this with our horizontal asymptote, and we've got it just going this way, where we would never have a part of our graph on this asymptote. So it could be that f of 2 is undefined. That could be true, but it doesn't have to be, because again, we could have something like this. Okay, part D is the only statement that must be true. If you look at these limits, this line of information up here, the limit as x approaches infinity of f of x equals L. If the limit as x approaches infinity equals a number, like it does in part D, then the line y equals L, that same number, is a horizontal asymptote. So because we have a horizontal asymptote at y equals 2, that means the limit as x approaches infinity is that same y value. So D is your only answer for number 4.